Restart the recording. Welcome to the second part of our live stream. We're going to look at our implementation of naively evaluated Datalog. So if you want to follow along, it's Sean Carib's Datalog Rust. And last time we implemented our verifying range restriction on rules, and we added some declarative macros. So let me get that open. Is it Datalog? Is it Datalog? Yeah, there we go. Okay. So here's where we were. We've got some warnings, probably because I updated stable Rust. Oh no, it just thinks we're not using those macros. Okay, so last time, I think it's worth looking at this, looking at what we did last time. So we made these declarative macros that let you write programs that are a little bit shorter than constructing the structs ourselves. So where this most showed up was down here in our test. So like we were trying to do this example that was from the original blog post that I'm taking inspiration from on this. Thank you, Alchemist. We'll look at that at the end. Please remind me. So we were building this set of facts, which I say facts, that's not correct. There's a set of rules which are advisor pairing ups, like this person advised that person. Okay. The author of this blog post, by the way, is Mistral Contrasted, in case you didn't know. And then you do this sort of like, it's sort of like the family tree thing, right? So what we did last time is, this used to be a lot more complicated, or at least a lot more noisy. And so we made these macros, which are like rules. So here we're defining a rule, and its head is an atom, and the name of the rule is advisor, and it has two arguments, a symbol. So a symbol is a literal, symbol is advisor, and symbol student. So this is looping over this list, this array, and creating rules out of those. And then we also extended it with a new set of rules. We extended it with other rules, which were this recursion thing. So either if you want to say someone is an academic ancestor, so they were either your advisor or you're an advisor of your advisor going all the way back. So that's what this defined. And so we have two more rules. One, they have the same predicate symbol, academic ancestor. And then each of these has vars rather than symbols. So like these were facts which don't have to be reunified, but we can determine new. I say facts. I use that too loosely. These are rules which don't have any body, so there's nothing to compute or unify. And for these, we want to unify the body with the head of the rule. So this most simple unification is like 1-to-1 between advisor and academic ancestor. And then this one is the recursive one. So you're saying that in this case, for if X is an academic ancestor of Z, then there's a relationship where there is an advisor, where X advised somebody and somebody Y, and that Y is an academic ancestor of Z. So at some point you'll recurse, and like this one will no longer match, but this one will. Okay. So that's what these are. These are all with variables instead of symbols. And that was a lot shorter than writing out all those structs, which we did originally with Quinn when she was on the stream. So if we hadn't done it like that, it would look more like this, right? Where we're defining atoms as structs and so forth. Okay, so that's what we did last time. And now what I want to do is something more akin to, let's run the tests real quick, because it'll print, I think it fails. We made it panic on one of the tests, and then it prints out the output. Right, so what we'd like to do is take this and parse it. Ooh. Okay, so let's go ahead and make a test where we can Let's just call it parses Datalog. Okay. And then what we want to do is potentially I think we did, I hope we did partial equality on all of these. Yeah. So there's on rule, which means it's on atom, vec of atom. And if we did it on program, then I think we're good. If we derived it for program. Yes, we did. Okay. So I think we're home free. What we can potentially do is make a new test. And we'll say let program, and we're going to make a raw string. Can we do it with brackets? I forget. Brackets not used in there. Do the quote bracket. No, let's put it in a text file. That'll be easier. I'd rather read it from a file than try to figure out. Actually, we can do that. Yeah. So let's do. We can do include stir. Make a new file. Let's say example.datalog. I don't know why. Here, we did that from the test, and I just copied again from there. Okay, there we go. So what we want our test to be. Okay, so let's say program text include stir, and we want example.datalog. Okay, so we're not actually using that in this test yet, but what we want to do is do something like parse. We want to do assert eq parse program text, and these are going to be results, so we're going to unwrap. Like, we want to make sure that our parser actually works, and then what we want to do is make sure that it equals this program that we constructed up here, right? So we're going to go up. Where's our example test? Right, so let's take this and just copy pasta here, and we can remove those, right? Because this should be equivalent, right? Program. Okay, so we need to define parse, and here's why I might actually make a new module. We haven't done this in the program yet, in this crate. So let's make parsing, and then we're going to this is going to be our mod, so we'll save it in Datalog source, and this is going to be parsing.rs. Okay, so this is going to contain all of our parsing stuff, and what we want to do up here is use, let's actually pub use. This is not a thing that we're going to ship, but we want to make a function that is parse, and this is going to take the text of the program, which is a stir. We don't care what the lifetime on that is, and Here's where it's going to get fun. This is going to be iResult of program. Yep. We're going to have to use crate star actually. iResult, and I forget what the actual thing is here. So let's just say for now this doesn't return anything. But we're going to get nom in here, and let's just do that. Cargo add nom. Okay. So now we have nom. This is good. Let's look at the documentation for nom. You can tell I've looked at nom before. Now, I've used nom most successfully for Advent of Code. So if you're interested in learning some Rust for Advent of Code, or doing Advent of Code with Rust, it's actually really great for it. But if you know how to use nom, because it like the favorite thing in Advent of Code is we have this crazy text-based data format that you get to parse. Good luck. You're going to spend most of your time on that and not solving the rest of the problem. Well, nom makes this pretty easy, and as I said, it's eating data byte by byte. So we're just going to start a section up here. We're going to use iResult, and then what I need this to do is this is going to return iResult, and let's look at the type of iResult. I think it's a type alias. Yeah, it's type alias. It is a result of the input type I, the output type O, and the error type E. And the error we don't have to define. We don't have to define the input type and the output type. Okay, so this is going to be I of stir, right? And we probably, I don't know if we need a lifetime on that, but we're going to turn a program. Okay, this does not compile. So expected result, we didn't return a result. So we're going to say, okay, for now, we're going to say, okay, program default. Oh, it doesn't implement default. Back. So we're just empty rules. Okay. What's wrong here? Oh, right. So we have to return a tuple of the input type. So your parsers always consume some amount of the text and return the rest, right? So we're always going to return, and then, right, we have a problem down here with our test, by the way. We want to say let underscore, because that's the text program. I think that's what it's supposed to be. Result in input type, output type. Okay. Finish solve. Oh, yeah. Okay. All right. What's wrong there? Oh, that's not what I want to do. I want to do unwrap.1 because our parse function returns it's okay, and then the tuple is text and then the program, right? So let's see what it's complaining about here. Private function pub. That's a problem. Oops. Okay. Now our errors are gone. So how we go about parsing Datalog, right? So similar to how we want to construct it with those macros, we want to construct parsers to handle those things. So let's make a fun for term. And this is going to take text, which is a str. And so all of these are basically going to have the same pattern, and it's going to return a term, right? So in our case, what we're going to do is this is the base level thing, but it has two branches. This is an enum, right? So we need to, let's look at the docs for nom. It has a bunch of combinators. So let's see here. That's not what I want. Branching combinators. So this is test a list of parsers until one by one until one succeeds. Okay, so we could let's define. We'll do something similar to this, right? We'll define one which is not term, but this is symbol, and then we'll define one which is var, right? And we can actually use those macros that we did down below, but that may not be possible. Let's see. Okay, so for a symbol, what we want to do, let's define this. This is this alt combinator. So let's use nom branch alt. Did I put too many colons there? Yeah, my stuff was in the way. Alt. So this is, we want alt, and this is going to take a symbol or var. And that's really all we have to do. I think this is the beauty. Now these don't, you know, the errors are propagating up here because we're not actually returning the correct thing here. But now we can go, so let's, you know, this alt is a parser. This is one of the beauties of nom, is that, and actually we need to pass it text, is that you can use its combinators and just define your stuff with those combinators and just pass the argument through. Okay, so for symbol, what do we need for symbol? We need we need something that's like surrounded by quotes, right? So let's look into the other possibilities here. So there's sequences. Aha. Okay, so we can have delimited. So matches an object from the first parser and discards it, then gets an object from the second parser, then finally matches an object from third parser and discards it. This is perfect for quoted strings. So let's do that. And let's look at what delimited does. Okay, so it takes a first parser, second and third parser, and it returns a function which, given the input, returns an I result which has the input and an output of the second type. So G, the type of this is it has to be a parser that takes an input and outputs type O2. So that covers what we want to do. Here's some examples. So we'll use tag. This is actually probably the exact thing we want to add. Let's just take these things and drop them in here. And we're going to do, so let's say let contents is delimited, and we're going to say tag of quote, right? And then we'll do the same. So it's going to end with a quote. And the second is going to be, we need something that just consumes all characters. So let's look at the different modules here. Probably want bytes or character. these will be useful with like white spaces and things. So you can recognize one character. We probably want to use car because we want to make sure it's UTF-8, right? So we need to take car and combine it with a repeater of some sort. Okay, we use nom character complete car. And we'll pass text here, and we need that question mark on the end. Now this is only recognize one character, so it's not correct. But what we want to do there is let's start with that, and in the end we want our symbol. We want term. Okay. And I forgot, this needs to take text. Well, we call this remainder for safety. And this returns remainder. Term sim contents. Okay. So we'll probably have to do some fix up on that. Note, yeah, this is not correct. What's going on here? Yeah, char returns a character, not a string. So I think that we need to figure out how to do that. How to consume entire strings. Is it multi? No. We want many 0. Right, so sequence? No. Multi. Many 0? I don't think we want fill, right? We don't want that. Right, so in this case they're saying, you know, ABC returns that. Many 0 is probably what we want. Because there's no requirement that the symbol actually have anything in it. So many 0. And we've got to import that. And then the other thing we need to do is now this is a vec of cars, and so we need to convert it to a string. I guess we could say the other option is we could do interesting. You can push individual characters. So we have a vec of characters. Does string implement from iter vec of car, or from iter car? Extend, possibly? Extend of car. The thing I'm trying to avoid here, by the way, if you're not following, the thing I'm trying to avoid is we know that this parses UTF-8 characters, right? Not bytes. So what we want is to take this. Okay, we'll have to see what the error there is. But we want to take this vec of cars and turn it into a string, like capital S string. So yeah, it implements extend from iterator car. It does take from iterator. Okay, so we can say string from iter, right? Contents. Now the question is, what else is wrong here? Okay, let's ignore that. Oh, we didn't implement partial EQ. So let's fix that real quick. I thought we did. Struct program. I don't know if there's a reason why we couldn't. Nope. Okay. Got rid of that error. All right. Parse error is not. Register parser car is not satisfied. Sorry, let's look at the docs for nom here. General person combinators, no. Okay. So this recognizes one character. Excuse me. Right, it'll return an error if there's not enough input data. Okay, so this, right, the input type has to be implement slice, range from usize, plus iterator. I wonder if that trait bound is the problem. Okay, let's break this up into multiple lines because we're getting into some complicated highlighting here. Rust analyzer reformatted for me. Okay. Let's look at the errors more in detail. So chart input length is not satisfied. Interesting. Parse error is implemented. Okay, that's a suggestion. So nom error for string does not implement parse error for char. I wonder if we say byte. If we go away from the maybe we say any. Yeah, it's probably any character. Except that let's use any char and see if that works. Okay, so that was the I think the issue was that char is expecting a specific. Yeah, okay, that's the problem. I was just using it wrong. It's expecting a specific character. Right. Now we need to make sure that the only thing that I think is left to do here on symbol, and this is the nitty gritty. This is the hard part. When we get up to higher level, it'll be easier. We need to make sure that we can take any character that's not a double quote, right? So let's look at that real quick. So we need some kind of predicate. Combinator. And that's another way we could potentially describe it is, yeah, let's try, rather than any character, let's say it is many zero of nom combinator not, and we have to be careful about importing that because no we don't. Not is fine to import, and we want char of double quote, right? So we just want to make sure it's not anything I would actually prefer this to be a predicate that's not like that, because I think that might be zero width. Succeeds if the child parser returns an error. Okay, so here you're saying not alpha 1, it returns empty. And here if you, yeah, okay. I don't think we want not. I think we want something like a predicate. Branch possibly? No. Permutation? No. See combinator if there's something in there. Verify. This could work. Okay. We don't want a streaming any char. We want complete any char. Okay. So we're gonna say we're gonna put this back to any char, right? And then we're going to add this combinator, which is verify, nom-combinator verify. One of the things that I ran into when doing advent of code in Rust, I didn't get through the whole thing, but I got through a lot, was that if you're using nom, you get a lot of these like big import branches, and it gets ugly really fast because it's like this highly factored library, and I kind of sometimes wish that they would put some things in higher namespaces and or have a prelude or something. Okay, so here verify takes a parser and a predicate closure. So let's say yeah, that is like alpha 1. Any char is going to give us a stir, I think. Let's see here. Why don't we just put verify in here and give it that, and then see. So you can like type inlays. So this is right like that. We'll just say true for now. And let's see what type it says that is. So it is a reference to a character. So we can say C. C not equal double quote. And we're going to have to borrow that, aren't we? No, not equal. This is not TypeScript. Sorry, folks. Okay, do we need that reference? Why don't we say ANSI? There we go. Okay, so we're basically saying give me any character that is not a double quote. And that'll like prevent us from being too greedy in that. And I really would love this to go on multiple lines, but I don't know if it's going to let me. Or if the formatter is going to jack me there. Okay, so so now we parse a symbol. Ooh, we should write some tests for this. Let's do a test real quick, and for the moment, I'm going to comment these out so they don't cause a problem with compilation. Config test, mod tests. Right. Yeah, we'll make a test, and let's say parse symbol. And this, all we have to do is make a string that will parse as a symbol. So let's say I'm going to do this first. Term sim foo. And let's say let result, and here's where we need to like dump the remainder of the string. We're going to say symbol, and we're gonna quote foo quote. Okay, unwrap assert equal expected result, right? Okay, and what's going on here? We need to use superstar, use create star. Oh, remember this needs to be a string, an allocated string, not a stir. Oh, okay. Now it's not complaining. Okay, so let's run this test. Can we do code actions with that? No. Okay. Okay. So yeah, that test is going to fail. So tests, parsing test, parse symbol. So parse symbol works. Let's do cargo test parsing colon, and then that'll just run those. Okay, so symbol works. Let's do var, which is going to be somewhat similar but not delimited, so it might be a little bit easier. So let's say remainder name, so the name of the variable is going to be and here's where we're going to do probably some more combinators. I think the syntax is always, it's like Erlang or Prolog, it's always initial caps for a variable. So let's see if we can do something like that in here. Okay, we could do right. I think we want oh, this is interesting. Maybe we could have done that. satisfy. Let's go ahead and refactor symbol. Instead of verify any char, let's do satisfy, because that's basically what we wanted to do. Satisfy. And let's just replace this with satisfy. Okay. And then, yeah, okay, that's cleaner. So anything that's not a double quote. Okay. Let's restore term, because what we'll want to do is test term after we have tested symbol and var. Okay, so what we want is something like alphanumeric, right? But let's get a predicate on the first character. The other way we could do it potentially is yeah, let's do that. So let's do a comment. There's a combinator that is like two things in a row, right? Excuse me. No, sequence is a pair. So you get a pair, gets an object from the first parser, and then gets another object from the second parser, right? Okay, so let's say pair. Is it going to let me import that? Yeah, non-sequence pair. Okay, so the first one we want to do is we want to do satisfy this char, and that let's look at the Rust documentation for char, because I think it'll be is alphanumeric is probably one like is uppercase. So it has two uppercase. Oh, is ASCII uppercase. That's what we want. Okay, so we'll say is ASCII uppercase. All right, so that'll make sure that the first one is an uppercase letter, and then we have alphanumeric 0. And this is text. Okay, and we'll put the question mark there so that we return any errors that fail, like if any of this fails early. Okay, so the name here is actually going to be a pair of initial and rest, right? And what we want to do is combine that. So honestly, I'm probably going to use format. The initial is going to be a character and rest is going to be a stir. So format is going to be the easy way to handle that. So then let's say, okay, remainder, and we're going to say term var, and we're going to give it format of initial and, oops, rest. Okay, so now let's quickly test var, parse var. And let's see, so let expected, and you know, I think I was doing this the hard way. We have those macros. Let me say this is simbang, and let's remove that. The macro didn't come down in here. Or was it symbol? No. All right. Well, let's back that out. So our expected here is term var. Exceptional is the name of the var. Right. And then we'll say result parse var, and it's just going to be the text exceptional. Unwrap it because we want to make sure that any failures crash the test, panic the test, assert equal expected result. Okay. And let's run those tests again. Okay, parse var failed. What happened? Result unwrap on an error value, incomplete size 1. So I'm guessing what happened is this was not satisfied. So what I might do then, instead of pair here, let's do we'll just I used remainder in a lot of these, but let's say initial equals satisfy. And this is one of the nice thing about the combinators here is you don't have to use them. You can chain them together yourself. So we'll go ahead and call this one remainder, and rest, and this is alphanumeric 0, and we give it text question mark, and then we don't have to have this combinator. Like, they don't have to be together. And what we should get is this is equivalent, right? But what we should get is hopefully the error happens on a different line. We'll see. No, incomplete size 1. So what's wrong there? Let's throw in a debug. And let's throw one here. Right? We may not finish this today. I need to wrap up soon. Okay, so initial, we got E. And then, so it did print that out. So in other words, it didn't return here, because this question mark injects a return if the result is error, right, from the result. It didn't return, it didn't happen here, it happened here. Do we use the streaming version? Ah, this is the problem. It imported the streaming version, not the complete version. That's the issue. We want to we know we have the entire text. We're not going to bother with streaming. Let's. Okay, that time it passed. Okay, and we're not using pair anymore, so we can drop that. Okay, so now we know term. Let's do some quick examples on that. Parse term. So the reason why we want term is that, like, in the head of our rules, the atoms, the arguments to these atoms can be either symbols or variables. So that's why we want to have term. And then what we'll do is we'll do something like on atoms, we'll do, like, let's read some, some rule name, and then we expect parens and a comma separated list of terms. Okay, so parse term. Let's, honestly, we can do the same as these, and we'll just say we're going to call term here instead of var and symbol, right? And that should work. Okay, cool. So we know our alt here thing worked. Okay, and let's make a smaller one called term list. And this will be our comma separated list, because we know that down here in our example, right, or in our example data log, this is going to be comma separated with optional spaces around terms. So we want to, this will be stir vec of term, right? So always the input type first in this return type, and then what you expect to parse out of it comes as the second argument to that generic. Okay, so we're going to need to do something like let's look at some of their recipes, because I think they have ones where you can eat white space before and after. Right, so we could do something like this. Wow, this, yikes. Okay. We're already using delimited combinator value. I don't know what that's used for. I don't see that. Okay, well, let's just crib their thing and then make it work. And we need to import nom error, parse error. This is complete multispace. Okay, so now we have a white space combinator. And so let's do, this is going to be delimited. We're going to white space wrapping term. And then we're going to have tag of comma. I want to have a white space. No, not delimited. We want not delimited, because we want it to be any number, right? Not just two that happen to have a thing in between them. So sequence. No. Multi. Probably many zero, right? Except we want commas between them. Separated list, here we go. This is what we want. Right, so this returns a vec of that, and your separator is the first one. So we want separated list 0, tag, and then we want term, and we'll give that input. So not input, text. So you can see here when you get the basics of like the hard stuff of byte by byte, character by character, you can start to build up these things that are really pretty powerful. Okay, so now let's take the last 5 minutes and do atom. And what we want to do here is, this is an iResult, right, of stir and atom. Okay, and so what we're going to do is, let's do this kind of like we did var down here. Let's remove the debugs from this since it's working now. We want to do it multi-step. So the first part is going to be the predsim. And we want to say this is going to be alpha numeric 1. Except we might need to do it like var, because we need to make sure that the first one is lowercase. So why don't we say predsim 0 is satisfy c dot is ASCII lowercase text, and we'll say text predsim, so in predsim is that, and then we'll say satisfy, or no, not satisfy, we just want alpha numeric alphanumeric 0 text. So now we have the pred sim, and let's just redefine that because it needs to be a string format, and we'll say pred sim 0 pred sim rest. Let's just not conflict those. That'll be easier. So you know, you don't have to use format here. You could use some things where you like push a character and then push stir on the end, and like that would be fine. I just find format a little bit faster in this case. Okay, so now we have the predicate symbol, and then we need to either have thank you, Isaac. Good night. So we need to either have parens and a term list, or nothing. So let's see if there's a combinator that lets us do that. Okay, so it would not be non-multi. You can tell it's getting the end of the stream. I'm having trouble talking. Okay, so we need something that's like optional parser, right? Right. Okay, so what we're going to do here is we're going to say let terms, so this is going to be the remainder, terms opt, and we're going to use that. Okay, so now we're going to say we have a delimited, and this needs to have opening paren, right, and a close paren, and then the second one is going to be term list, the thing we just made with separated list of terms. Now we should probably go back and test term list, right? Okay, so if this fails, it'll mean that like something was really weird going on. So we made an optional term list. You don't have this very often in Datalog programs, but it is okay to have a pred sim with just a dot. Okay. So, and this will probably be where we end the stream. I'm running out of steam. Okay, so now we can go okay, and remainder, right? And then we're going to make an atom. And what does that take? It takes the pred sim, and the terms is going to be terms.unwrapper default. And what that is saying is terms, you know, okay, so it doesn't actually, it can't infer what this is. So we know that this is going to, term list returns a vec of term. If we parse that that list of terms that are separated by commas with oh, we didn't put our white space combinator around that, did we? Let's do that. We need white space around terms. So it's going to be a separated list of terms that have white space potentially around them. Now we're getting an error. Okay, so this is returns option vec of term. What did it do wrong? Oh, right. So I did not pass the text. Okay. So now we know that terms is an option vec of term. Unwrapper default will, if the value is none, it'll return the default value for the parameterized type. So if t implements default, which vec does, it's an empty vec, then our terms will need to be a vec of terms, and then they'll be empty, which should be correct there. So so let's do let's parse Atom, and I think that'll be sufficient. Um, Atom, predsim, and let's do no args, toString. Okay. No, not two lowercase. Come on, toString, please. And then the terms will be an empty vec. So we'll do an example that has an empty vec. And let's see about parsing that. Atom, and we are going to say no args. Right, so it's just a bare Atom name with no arguments. And then we'll just do that. Okay, and then let's do one that has args. And this one will be a little bit harder because we're going to have the terms in it. And we'll just say args is the name of it. And the terms are going to be a vec. And let's do some variables so it's easier to type and we don't have to worry about double quoting or escaping strings. So let's say term var x1 toString, term var x2 toString. I do not recommend you name your variables like that. Okay, and then we're going to parse. So what would that program be? That would be an Atom parsing of args, and it has parens x1, x2. And we can kind of force the white space question by putting white spaces in there. Okay. And let's do our expected result again. Assert. Okay. And that works. Cool. So I think that's a good place to stop. We got pretty far. We will maybe next time. Maybe we'll take a break from Datalog. Maybe we'll satisfy Mitch's request of playing with integrating tree sitter into an Elixir as a NIF. That could be pretty exciting. That kind of bridges our Rust and Elixir. But we got pretty far in parsing this, so we would be able to parse all the way up to here, and that might be a useful thing to test real quick. So what we would love is for this to return a program, but if we get to the dot, it's not going to know how to parse anything beyond there. So let's do that real quick. Parse example. And I think I did this and no, let's do that next time. That's too much work for this time. So I'm going to make a commit here real quick. Let's see what those warnings are. Those are all about the it's used. What are you talking about? Oh, it's just not used because we're not exporting. Yeah, we're not going to care about that right now. Hello? Okay. And let's add example. Okay, so beginnings of parsing Datalog. And then, yeah, I say with that kind of wraps it. Thanks everybody for sticking it out for 2.5 hours. It was great fun, and we'll see you next time. If you have any questions, I'll be online prepping my YouTube VODs for later. So please feel free to drop them in the chat. Thanks. Have a good one.